Hello everyone! So we are the group 1 and now we are experimenting about the Boyle's Law experiment. So this experiment is all about Boyle's Law experiment. So according to an Irish chemist, Robert Boyle, who formulated the Boyle's Law, pressure and volume are inversely proportional. Where pressure increases, the volume decreases and vice versa. These are the material that we are needed. Now let's try our lung model. When I put pressure inside or exhale, the volume of the lung or the balloon decreases. However, if I breathe in making the pressure decrease, the volume of the lung or the balloon increases. This experiment shows how Boyle's law works and how pressure is inversely proportional to volume. When I took out air from the empty bottle, the volume of the balloon increases, and as I put more pressure inside the balloon deflated.
In this experiment, we will use 190 ml of soft drink. First, place the two Mentos inside the balloon and attach the balloon to the top of the bottle. Then quickly drop the Mentos into the bottle and observe the reaction. Watch as carbon dioxide gas is released, causing the balloon attached to the bottle to inflate slightly. This demonstrates Avogadro's law by showing the relationship between the volume of gas and the number of gas molecules. Because we used a small amount of Coke and only 2 Mentos, the reaction released a small amount of carbon dioxide. These caused the balloon attached to the bottle to inflate slightly, forming a small round shape. This shows Avogadro's law, which says that the volume of gas increases as the number of gas of molecules increases, as long as temperature and pressure stay the same. Since only a little carbon dioxide was released, the balloon grew only a little. This simple experiment also shows how volume, pressure, and temperature are connected. Reflecting on the simple experiment demonstrating Boyle's law, Charles' law, and Avogadro's law, we realize how valuable hands-on activities are in teaching science, particularly in thermodynamics. It is also important for the learners to be creative and innovative in deciding what materials we can use to ensure less cost and much effective. In addition, each of these laws offers a unique perspective on how gases behave, but they all share a common theme: the relationship between physical properties like pressure, volume, temperature, and the number of gas molecules. By connecting these principles to practical experiments, students can see that science is not just theory, but something that happens around them. Constantly, in teaching science, especially thermodynamics, using experiments like these makes complex ideas more accessible and engaging. It encourages students to actively think, experiment, and observe how these laws shape the world.
Let me introduce to you the Charles' Law experiment. Unfortunately, my experiment didn't work due to the absence of alcohol content that I used. It is not working, but I have the video from our source. So this is our materials. First is we have our bowl, alcohol, bottle, and match, and a piece of paper. First is we need to put water inside the bowl, and then we need to sprinkle the alcohol into the bottle, and then we put it into the bowl. Then we use fire to lift it up the water. Here we go. So that experiment explained that the Charles' law, the water condenses to moisture on the bottle, causing lower air pressure to reach equilibrium. That area must decrease so the water rises in the bottom.